In the early 20th century, Alfred Wegener proposed that continents were once all connected to form a vast supercontinent named Pangaea. He suggested that Pangaea broke up and that continents have been drifting apart ever since. In the centuries since Wegener, geologists have learned that Pangaea is only one of several supercontinents that have formed and that have broken up and dispersed during the past few billion years of Earth history. Supercontinents form when subduction consumes an ocean basin and the continents that were once on opposite sides of the ocean collide. Supercontinent breakup happens when rifting splits apart a continent. Then, seafloor spreading produces new ocean lithosphere, so continents on either side can move apart. Let's look in more detail at Pangaea's formation and dispersal. Pangaea came into existence at the end of the Paleozoic when Laurentia, a landmass composed of North America and Greenland, collided with Gondwana, a landmass containing Africa and South America. Structures such as the regional scale folds visible in the Appalachian Mountains of the eastern United States are relics of this collision. A dinosaur living in early Mesozoic could have walked from Canada to South Africa in Pangaea. In the Triassic, narrow continental rift basins began to develop in Pangaea as the supercontinent began to stretch apart. Beginning in the Jurassic, however, around 200 million years ago, Pangaea began to break apart. Rifts formed along what is now the east coast of North America, and when rifting succeeded, the northern part of the Mid-Atlantic Ridge became established and the North Atlantic started to grow. Eventually, South America split away from Africa and the South Atlantic started to grow. In the meantime, complex plate geometries developed in the region between North America and South America, yielding the Caribbean Sea. Note that at various times, portions of the interiors of the continents were flooded by shallow seas. Now, let's look at the last 100 million years of this process by focusing our attention on the seafloor itself. In this animation, different colors represent the age of the seafloor. The blue represents the oldest, and the red is the youngest. The widths of the color bands represent the rate of seafloor spreading. Where the bands are wider, spreading is happening faster. The bands are widest in the southern part of the South Atlantic, because this is where the fastest spreading rate along the Mid-Atlantic Ridge is taking place. Notice how the oldest ocean floor lies along the sides of the Atlantic Ocean, while the youngest occurs along the Mid-Atlantic Ridge. On average, seafloor spreading in the central North Atlantic happens at about 3 centimeters per year. At this rate, the ocean basin is getting wider at a rate of about 3 kilometers per million years, or, put another way, 3,000 kilometers per 100 million years. This rate is therefore compatible with the concept that the ocean started to form about 200 million years ago because it's now 6,000 kilometers across.